What is wrong with this SQL table? In part one of this video, I said the problem was redundancy and the solution was to normalize the table, to pull the product into their own table and just reference it from there, reference product data from product data table. But there's a little bit of issue with that. Product name is fine. Names of products don't usually change, except in special cases, but product prices change, right? Products can go on sales, prices can get updated. If you normalize price into a separate product table, there is a problem now. iPhone used to be 1,000, but now there are sales going on and iPhone is now 900. One order was placed 3 months ago when iPhone costed 1,000, and a new order was placed yesterday when iPhone now costs 900. Both of them are referencing the same product row that says 900 because the new price is now 900, right? So we have lost the price that the initial customer actually paid. Now that's a real problem. Imagine if the initial customer comes back for a refund. What price do we refund them? The current price or the price they actually paid? We don't know the price they paid anymore because we did not store that price. In the real world, you would often need to store the price at the time of purchase. The textbook answer of normalization doesn't hold up here because business logic is now involved. There are a few approaches. Approach one, which is the most common, is to store the price at purchase in the order items table. Directly in the order items table, store the price that was paid when that order was placed for that item. Now, each item will hold the price that the customer actually paid at the time when they placed the order. The products table will still hold the current price for new orders, but historical orders are now logged at the price that was active when they were placed. This is not redundancy, it is intentional denormalization for a specific business reason. Now, approach number two is to save betting snapshots. I was talking to someone and they work on a betting platform and they use this approach. Every time a bet is placed, they take a full snapshot of the relevant data associated with that bet and they store it as a JSON object alongside the bet record. Even if the odds change after the bet is placed, the record holds exactly what the odds were at the moment of placing the bet. We can use this for our pricing as well. It's called the snapshot pattern. But there's a trade-off with this approach. We are going to be duplicating a lot of data and that's storage cost. If it works for the situation, it works. Approach number three is price versioning. Instead of storing one price per product, we store a history of prices. So every time the price changes for a particular product, a new version of price is created for that product. And each order references the specific price version that was active when the order was placed. We would have the products table and then we'll have the product prices table and then we'll have the order items table. So a new additional table. So each order line doesn't store the price itself. It stores a reference to the specific price version that was active at the time that it was placed. And in this case, with versioning, the